All right, in question 5, now we're dealing with, we want to estimate the population proportion rather than the average. So our scenario is that we want to study workers at a large company, and we're going to sample 16 of them randomly and ask them whether or not they'd be willing to take a reduction in their salary in return for extra vacation. And this was their responses. And so we want to estimate by making a confidence interval, a 90% confidence interval, what's the population proportion who would accept this pay cut, who would accept this deal. So first thing we want to do is we want to calculate our sample proportion and our sample standard deviation. So our sample proportion, we want to estimate the number who would accept, who would say yes to this deal. So we'll take the proportion out using this sample of people who would say yes. So we want to count, remember our sample size is 16. We want to count the number of people in our sample who would say yes, who had said yes, and divide that by 16, our sample size. So I can count, there's 1, 2, 3, 4, 5. 5 people who said yes to this deal, who accepted it. So our sample proportion is 5 out of 16, or about 0.313. So then next, my sample standard deviation. If you remember, the sample standard deviation, our formula for that is we take our proportion times 1 minus that proportion and divide by your sample size and take the square root of the whole thing. So I want to take the square root of 0.313 times 1 minus 0.313 and divide by my sample size, which was 16. If I plug this into my calculator, I should get 0.1159 approximately. So then I want to find my margin of error. My margin of error, when I'm estimating a population proportion, is the z-score corresponding to my confidence level times my sample standard deviation. My confidence level is 97%, so 1 minus that is 3%. So the area in both of the tails, so the area to the right of positive z and the area to the left of negative z, the opposite of my z-score, the total area in both those tails is 0.03. So the area in just one of them, because the normal distribution is symmetric, is half of 3%, which is 0.015. Similarly, the area to the left of negative z is 0.015. So now I'm going to look in my z-table and find the z-score with an area to the left of 0.015. If I do that, I can see, let's get rid of this, I can see that I see 0.015 right here. And the z-score corresponding to an area to the left of 0.015 is 2.17, negative 2.17. So negative z is negative 2.17, so that means that z is equal to 2.17. So the last thing I need to do is check my assumptions and make my confidence interval. Construct my confidence interval. Okay, let's do a quick check of assumptions. So is our sample large enough? Is n times our sample proportion greater than 5? N times 1 minus our sample proportion greater than 5? Let's see, 16 times, so 31% of 16 times 16 is just a hair over 5. And so 16, so let's see, this is good, just over 5. And then 16 times 1 minus 0.313, so about 70% of 16, that's definitely greater than 5. All right, let's check a couple more assumptions. Do we have a random independent sample? Well, we're told it's random, and we'll assume independence because we're not told otherwise. And then, is our sample size less than 10% of our population? Well, it says it's a large corporation, and our sample is 16. So a large corporation, large, I would imagine, several hundred workers at least. So 16 is definitely less than 10% of several hundred. So this is good. So that's all our assumptions. So now let's construct our confidence interval. So remember that our confidence interval is given by our sample proportion plus or minus our margin of error. So this is equal to 0.313 plus or minus our margin of error, which would be 2.17 times our sample standard deviation, which is 0.1159. If I plug this product into my calculator for my margin of error, I should get about 0.252. So if I now plug in 0.313 plus or minus the margin of error, I should get the interval 0.061 to 0.565. In other words, we're 97% confident that the percentage of all workers at this corporation who would accept this deal is between 6.1% and 56.5%.